Hey everyone, welcome back to MTechZudo, your space for professional tech learning. In this episode, we are going to explore the lower layer of the OSI model. The physical layer, the data link layer, and the network layer in full detail. These layers form the foundation of all data communication, from the moment data leaves your device until it's routed across the world. So let's power up and go layer by layer. First, the foundation of networking. Physical layer. The physical layer is the first and lowest layer of the OSI model. Its main job is to transmit raw bits, zeros and ones over a physical medium. Think of it as the infrastructure that makes communication possible, the roads and highways where your data travels. It defines how data moves, not what the data means. Key functions of the physical layer. Bit transmission converts digital data into electrical, optical or radio signals. Physical topology defines how devices are physically connected, bus, star, ring, mass. Data rate control determines the speed of transmission, like 1 Gbps to 10 Gbps. Transmission mode: simplex, one way; half duplex, both ways but one at a time; full duplex, both ways simultaneously. Physical components: cables, connectors, switches, hubs, repeaters, and ICs. Real world examples: Ethernet cable, fiber optic cables, Wi-Fi radio signals, network interface cards, repeaters and hubs. So basically, when you plug in a LAN cable or connect via Wi-Fi, the physical layer is what's actually carrying your bits from one point to another. Now, data link layer. Reliable local delivery. Now, once the physical layer transmits the signal, the data link layer takes over. This is layer 2 and its main goal is to ensure error-free and reliable data transfer between two devices in the same network. You can think of it as the traffic manager for the local network. It makes your data frames don't collide, get lost or mix up. Functions of data link layer. Framing converts raw data bit, the physical layer, into data frames. Addressing uses MAC addresses to identify devices uniquely. Error detection and correction uses CRC, cyclic redundancy check, to detect transmission errors. Flow control ensures one device doesn't overwhelm another. Access control manages which device can use the network medium. Sublayers of the data link layer. MAC, media access control, controls access to the transmission medium. LLC sublayer, logic link control, handles error checking and frame synchronization. Real world examples of data link layer: Ethernet IEEE 802.3, Wi-Fi IEEE 802.11, switches and bridges. PPP, point-to-point protocol, ARP, address resolution protocol. So, how frames are sent or received? Sender workflow. Network layer hands a packet to data link. Data link encapsulates packet into a frame and adds source destination MAC address. Frame is appended with CRC, cyclic redundancy check, trailer, and converted into signals for the physical layer. Now, receiver's workflow. Physical layer converts signals back into bits and reassembles the frame. CRC checked. Corrupted frames are discarded if MAC matches headers, tailors removed, and payload passed to network layer. Now, the third layer is network layer. Logic addressing and routing. Next, move up to layer 3, the network layer. If the data link layer delivers data within a local network, the network layer ensures that data can travel between different networks. This is where IP addresses, routing, and path selection come into play. Main functions of the network layer. Logical addressing assigns unique IP addresses to each device on the network. Routing determines the best path for data packets to reach their destination. Packet forwarding moves data packets through intermediate routers. Fragmentation and reassembly splits large packets into smaller ones to fit network limits. Error handling and diagnosis using ICMP like the ping commands. Common protocols of the network layer. IP, Internet Protocol, core of this layer. IP provides addressing IPv4 and IPv6 and packet headers containing source or destination IPs, TTL, and fragmentation flags, essential for inter-network communication. ICMP, Internet Control Message Protocol, used for diagnosis and error messages. IGMP, Internet Group Message Management Protocol, used in multicasting and routing protocols. OSPF, RIP, BGP. Devices working at the network layer are routers, layer 3 switches, gateways. Encapsulation or forwarding. The network layer encapsulates packet into frames for the next hop and uses routing decisions to forward packets toward their final destination across multiple links and networks. When you open a website, your computer doesn't know exactly where that server is. The network layer takes your data packet, assigns it an IP address, and uses routers to send it across multiple networks until it reaches the target destination. Let's quickly summarize that what we have learned about the lower 3 layers of the OSI model. Physical layer transmits raw bits through cables or signals, focuses on hardware. Data link layer packs data into frames, adds MAC addresses, and ensures local delivery. Network layer handles IP addressing, routing, and packet forwarding between networks. Together, these 3 layers build the foundation of networking. They make sure your data can travel from one device across networks and reach anywhere in the world. Visualizing the journey, bits, frames, packets. An end-to-end transmission traverses layered transformations. The physical layer sends raw bits as electrical, optical, radio signals. The data link layer groups those bits into frames with MAC addresses and CRC checks for local delivery. The network layer wraps payloads into packets with IP addresses and chooses routes across network. Each layer adds headers, tailors, enabling modular handling of concerns, and simplifying troubleshooting by isolating faults to a specific layer. Why mastering the lower layers matters. Operational reliability. Good physical design and proper layer 2 handling eliminate intermittent failures and maximize throughput. Security and segmentation. Understanding MAC IP boundaries enables effective network segmentation. ACLs and mitigation of spoofing or ARP related attacks. Troubleshooting efficiency. Most connectivity issues start at these layers. Cabling, duplex mismatches, MAC table problems, or routing misconfigurations. So focused diagnostics save time. Mastery of physical data link layer and network layer empowers network architects, operators, and security teams to design robust infrastructure and resolve complex faults quickly. Use this layered lens when planning, auditing, or troubleshooting any network. And that's all for today's deep dive into the physical data link and network layers, the lower layers of the OSI model. In the next episode, we will move to the upper layers, transport, session, presentation, and application, and see how they complete the journey of data communication. If you found this video helpful, make sure to like, share, and subscribe to MTechZudo and hit the notification bell for more professional tech tutorials from MTechZudo.